Okay guys, here we are with creating equations practice. So if you've taken the formative assessment, you can use this to kind of help you understand what it is that you need to work on. So we're just going to go over a bunch of problems, and you really should have done this on your own first, or tried to do it on your own. Watch one or two at a time, kind of that idea, to make sure that you're getting some help, okay? So the cost of, before I get started, remember there's the starting number, the growth number, the equation, which is down here, and the total cost when we ask the question. So we're looking at all four of these. So if you're only struggling with one of them, focus on that one that you're struggling on and just watch this to get help with that, okay? All right. So the cost of a birthday party at Classic Boone is $200 plus $4 per person. Fletcher invited 23 friends to his party. How much will the party cost? Okay, so the idea here, right, is that we're looking at the starting number. So you pay $200 just to rent it, okay? And then it's $4 per person. Now that $4 per person would be the growth, right? That for every person, we're spending $4, right? We're adding $4 to the cost there. So that growth is we're adding 4. And remember, with the growth, that's the one where the variable goes. Because for each person, we're adding 4 that many times, right? Okay. Erase that. All right, so the starting number would be 200 because that's just kind of like a one-time fee. Doesn't matter how many people come, we still have to at least do $200. So for our equation, we start with 200. We're adding 4 multiple times, so 4 times P, and that's going to equal the party cost, right? Okay. Now, to solve this, let's kind of think about it. So we have 23 friends coming to the party, right? So really, if I really wanted to, I could think of this for each of those friends, we're spending $4, right? So I'd be adding 4 23 times. Now, I really don't want to do it this way, do I? Okay. And so that's why for that repeated addition, right, we use multiplication. That's why for our variable, it's times P. Because we would then say, well, there's 23, so that 4 times 23, which is representing that plus 4 23 times, that would give us our answer, right? So 4 times 3, 23 would be what? That's a 92. So 200 plus 92 would be 292 would be the total cost. Okay. Number 2, a cell phone company charges $55 per month for unlimited minutes plus 25 cents per text sent. If you sent 100 texts this month, what was your bill? So, again, that growth number is the one that's got the per with it. So, we're doing 0.25 cents we're adding to our cost for every text we send. Okay? And we start with 55. If we send no texts, that's $55. That's our starting number. So I go 55 plus 0.25 times t, and that's going to equal our bill. Okay. Now, if I sent 100 texts, we would simply plug in 100 to that 0.25. Okay, 0.25 times 100 would be 25, plus 55 would give us $80. So our bill, we send 100 texts, would be $80. All right? Okay, let's just keep going through these guys. So Jade is stranded downtown with only $10 to get home. Taxis cost 75 cents per mile, but there's an additional $2.35 higher charge. She has to travel home, which is 15 miles away. Okay, so starting number, that is that additional higher. That $10 is how much she has to spend. We're not really using that, okay? So our start would be $2.35. Notice that 0.75 per mile, That's the one that's our growth. So 0.75, it's going to be per mile, so we times it by miles, variable, and we're adding it to the cost. So it's 235 plus 0.75 m is going to equal the cost. Okay. Now, her home is 15 miles away, so if we plug 15 in to the m, that's going to be how we figure out how much it'll cost total, and thereby we can say, is she going to be able to make it home on time? Yes or no. Okay, that's kind of what we're looking at here. So 0.75 times 15 would be 11.25 plus 2.35. It's going to give us 13.60. So we get, it's $13.60. So with her 10, it's not enough to work, is it? Okay. Now, if we really wanted to, we could figure out how far she could go with the $10. Okay. That's a different kind of question. Then it's what the cost would be. We'd say if the cost was $10, what would we end up with? And if that's the case, we would subtract 235 from both sides because we'd solve for the m. So 10 minus 235 would give us 0.75 m equals 7.65, which we would divide by 0.75, and we'd get m equals 10.2, or 0.2 miles. So she could go a little over 10 miles off that $10, but she's still gonna have to walk, unless she can scrounge up some money that can help her to make it the whole way there. All right, number 4. Jasmine's dad, I'm feeling like a different color now, is planning a surprise birthday party for her. He will hire a bouncy castle and will provide party food for all the guests. The bouncy castle costs $150 for the afternoon. Again, that's a one-time fee. And the food will cost $3 per person. Okay, per person tells us that's our growth. We're adding $3 for every person. So plus 3p. So our equation would be 150 plus 3p is going to equal the cost. Okay, if there's 50 people showing up, we put that in for p, and we solve. Okay, 3 times 50 would be 150. 150 plus 150 is 300. So it's going to cost $300 for 50 people. All right. All right. Now, Juan is considering 2 cell phone plans. The first company charges $120 for the phone and $30 per month for the calling plan that Juan wants. The second company charges $40 for the same phone, but charges $45 per month for the calling plan that Juan wants. What is the cost for each for a year? So, really we have 2 different situations here going on, right? So I actually need to do the A, the B, and the C, and the D for each of them, okay? So let's first do the first company. So 120 for the phone, so that's our starting cost for the year, right? We have to buy the phone. Then it's $30 per month, so that'll be adding $30 per month for the calling plan, okay? Adding to that cost of the phone to get the whole cost for a year. So the equation would be 120 plus 30m, and that's going to be the yearly cost for this cell phone plan. Okay, and if we're doing it for a year, we'd go 3 times 12 plus 120. 3 times 12 is 36, plus 120 would be $156, right? Oh, that's 30, not 3. I was like, something's not right here. It should be more expensive. That's because I didn't write my equation correctly. 30m. There we go. So it would be the 30, not 3 times 12, 30 times 12, which is 360, okay? Plus the 120 would be $480. Okay. Now, plan 2, it's $40 for the same phone. Okay, so that's our starting number. 45 per month, so we're adding $45 per month. Okay, so our equation here would be 40 plus 45m. Much cheaper phone, but the plan is more expensive. Okay, So again, we put 12 in right there, so I get 40 plus 45 times 12, and that's going to be our cost. So 45 times 12 is 540, plus 40 is going to be 580. So if we look at these two, it's going to be better to spend more on the phone and less per month than it would to go the opposite direction, okay? So, yeah. All right. Number 6, Virginia's painting service charges $10 per job and 20 cents per square foot. If Virginia earns 50 for painting one job, how many square feet did she paint at the job? Okay, so just to do the job, she charges $10. Then it's 20 cents per square feet, okay, per square foot. So we'll put F for foot. We're adding 20 cents for every foot. So our equation would be 10 plus 0.20 F, and that's going to equal how much the total cost would be, right? Now in this one, it says she earned 50, so that total cost is what we're looking at here. We don't plug it into the F, we're going backwards. So we'd subtract 10, giving us 0.20 F equals 40, divide by 0.20, and we'd get F, okay, which is what the number of square feet that were painted. So 40 divided by 0.20 is 200. So 200 square feet were painted. So that's one of those where they're working backwards. Now, we could also use this to say we had 500 square feet we wanted painted. Okay, we could plug it in and we'd go 500 times 0.20, which would give us 100 plus 10, so it'd be $110 for that. All right, Melvina only has $25 to get home. Her cell is dead, and so she needs to hire a taxi. Taxis cost $2.50 per mile. That's our growth, right? So plus $2.50. And there is an initial hire fee of $5. So that's kind of just to get the taxi to come let you get in. Okay, so that growth would be 50 per mile. She wants to get as close to home before she has to walk. Write an equation that will tell us how far she can travel and show how many miles $25 will get her. Okay. So the equation would be 5 plus 250 m equals whatever we're looking for, right? Now, because we're again going for miles, that would be equal to the $25 she has, okay? So we'd start off by subtracting 5, so I'd get 250 m equals 20, divide by 250, and we'd get 20 divided by 2.5, which is 8. So she could go 8 miles. Okay. There we go. Hopefully, doesn't tell us how far she's gotten. Hopefully she is closer than 8 miles. Okay. Or really close to 8 miles, I guess. Okay. We've got 8 and 9. Sam is deciding whether to just rent movies from Redbox or to sign up for Hulu Plus. Redbox charges $1.28 per movie. The Hulu Plus account costs $7.99 per month. If he wants to watch a movie every day, which deal would be better? All right. So, looking at this one, we've got two situations again, right? We've got Hulu and we've got Redbox. So, let's start with Redbox. So, Redbox charges $1.28 per movie. Now, if you don't watch a movie from them, it costs nothing, so our starting number is actually 0. Our growth would be plus $1.28 per movie. So for the equation for Redbox, it would simply be 0 plus $1.28 m equals that total cost. However, we can really just get rid of that part and just have $1.28 m. Okay. Now for Hulu, it's $79 per month. Doesn't matter how many movies you watch, so actually that's our starting number, and there's no growth because there's nothing per movie. So it would actually just be $7.99. You could put plus 0m, but that again isn't going to do anything for you. So it's just equal to the cost. So Hulu's going to be $7.99. Redbox depends on how many movies you watch, which depends on how many days we're talking about. So let's say we did a week. So I'd do 128 times 7. okay? If I did a week, that would be $8.96, okay? So if I did a whole month, since Hulu charges per month, okay, that would be 30 days. Let's just average 30 days. So I'd go 30 times 1.28, and that would be $38.40, okay? So I think we can probably say, as long as you don't care what movies you're watching, Hulu is probably going to be a better deal. If you care, well, then Redbox might be the better, and you just may have to spend more or watch less. Okay. All right, number 9. Florence is binge watching Netflix. He has already watched 2 shows. He decides to take the exponential binge watching challenge, which means he will have to double the amount of shows he watches every week. Okay, that word double means timesing by 2. So now instead of adding or subtracting, we're multiplying. So he's already watched 2 shows, so that's our start. So we start at 2, then we're timesing by 2. Now remember, when we're multiplying, we have to put the variable up here at the top, okay? And let's actually use D for day. Okay. So because repeated multiplication is an exponent, so it'd go to the D power equals the total number of shows, okay? So we're looking at how many he watches in a week, so that would be 7 days, right? So we go 2 times 2 to the 7th. Now, 2 to the 7th really means 2 times 2 times 2 times 2 times 2 times 2 times 2. Then our first times 2. So that's really what we're doing, okay? So that would be 4, 8, 16, 32, 64, 128, and 256. So in a week, we'll watch 256 shows. All right. So last problem here for the practicing, okay? You are breeding rats. You have already bred 12 of them. You estimate that you can triple the number every year. Again, triple definitely means multiplication. So our growth is timesing by 3 every year. So we make the exponent, right? We already have 12 of them, so that's our starting number. So I go 12 times 3 to the y, and that's going to be equal to our total rats. Now we want to know how many we'll have in 4 years, so I go 12 times 3 to the 4th power. So that's really 3 times 3 times 3 times 3, right? Times 12. 3 times 3 is 9, times 3 is 27, times 3 is 81, 81 times 12 will give us 972. Okay? All right, so hopefully taking a look at these has helped us to kind of see a little bit better how to make equations from story problems, and looking at that starting number and that growth and understanding what we're doing to create the equation, and then how to use it to solve things, okay?